Okay, guys, we're going to talk about the area of a trapezoid. There is a formula that goes with it. I'm going to teach it to you real fast. We're on the bottom of page 24 where it says area of trapezoid. And the way we started this out, these are two separate problems here. Okay, the way we started this out, and most of you started doing this the other day, was just dividing a trapezoid up into shapes that we know. And that'd be the number one way to do this. Y'all get to a standardized test or whatever, and you don't remember the formula, just divide it up into the shapes we know. Many of you default into doing that from our previous measurement unit. Okay. Anyway, the way I divided it up was two triangles plus a rectangle. My triangles, I needed to find this height right here. So I went over here and did Pythagorean theorem. And once I found that height, I did base times height divided by 2. Plus the rectangle, which was 18 by 15, and that gave me an area of 240. Okay, I did the same thing on the one that was graphed. This was a separate problem. You plot the points, you start looking at it. This is great. These are parallel. You can divide it up into a triangle and a rectangle. So just one triangle and a rectangle, since these were already right angles. Anyway, base times height divided by 2 plus base times height. So you can do that. No prob on the area of a trapezoid. These are the formulas that are involved. Now, let me show you a little bit of a shortcut, or let's develop a formula that would work on all trapezoids. So it says, what similarities are there between determining the area of a parallelogram and determining the area of a trapezoid? Well, I would say the similarities would be that height still must be perpendicular. That's going to be like the main thing that we look at. It says, recall the formula for the area of a parallelogram is base times height. So I have one down here where the entire base, if you look at the entire base right here, is from F to G. And then I know that my height can be out here. My height is 3. All right. So there's base times height. Parallelogram has both pairs of opposite sides parallel, but what happens if you divide the parallelogram into two congruent trapezoids? So this is what's possible on these. I can find a point here in the middle and divide this into a trapezoid over here on the left, if you can look at it, because these two are parallel, and these two sides are not. And then what's identical to this is flipped upside down on this side. Okay, so this one over here also is the exact same trapezoid. So basically this parallelogram is made of two congruent trapezoids. Okay, and it says to label this as base 1 and base 2. So this segment right here, from here to here, I'm going to call that base sub 1. But this one up here is also base sub 1. Those are congruent to each other. And this one up here is base sub 2 from here to here, which is 1, 2, 3, 4, 5. And this one down here is the same thing, base sub 2. All right. And then it says to go ahead and write the area of this thing like we were going to do at the very beginning. Well, what we were going to do is we were going to use this entire length from here to here times this height that was over here. That's what we said that goes on a parallelogram anyway, base times height. So if I continue to do that, well, this entire base is actually those two added together. So for the whole thing, I would write base 1 plus base 2. I would have to add those together first. And then I would have to multiply times the height. So this is really how you would find the area of the parallelogram. This would be for the parallelogram. Right? However, if we just wanted to find one of these, either this trapezoid or that trapezoid, we would still involve this height. It would just be half of this. So that is your area for a trapezoid. It would be base 1 plus base 2 times the height, all divided by 2, or all times 1/2. So this is our new formula. Okay, you can add it to your list of formulas. You know, we didn't put it over here on this during that test because we weren't doing trapezoids. And besides that, you could still go back and use these two, you know, to reason it out. But since we know this formula now, I thought it'd be good if we could just work a few problems dealing with it. Okay, it's pretty easy to use. And the good thing about this is you don't have to divide it up into rectangles and triangles. So remember, base 1 and base 2 are the two that are parallel. So it's going to be 18 plus 21. There's my base 1 and base 2 times the height, which is perpendicular, and then divide by 2. That's how you're going to get this answer of 312. Okay, when you type this in the calculator, this has to happen first before you multiply by 16 and divide by 2. Once again, it's the two that are parallel. All right, it's the two that are parallel are base 1 and base 2. So in order to do this, you better use the 18. That 30 goes for this whole thing because it's not marked. All right, so it would be 18 plus 30. That'd be your base 1 and base 2. And then the height would be 15, not 17, because the height is perpendicular. And then don't forget to divide by 2. All right. So that's how you do those. The hint on this one down here is to divide this up. We're doing a rough estimate here. You'll need to read this and get an idea. But if you divide that up, if you look at that shape, these two are parallel. All right. There's another one, and that's a trapezoid. There's another one right here. That's roughly a trapezoid. Those two are parallel. These two are not. You can divide this up and get a rough estimate of the cross section of this stream. What they're trying to do here is estimate the amount of water that flows through here on a daily basis. But they were having to divide this up into some shapes that they know. And of course, these end shapes right here, we could estimate those as being triangles. So you can do this. You need to read this problem. There's kind of your hints, though, and figure that out. You can rough estimate that cross-sectional area there. Let's look at a few more. We could do a trapezoid that does not have the height drawn in. So, of course, you know you're going to need to draw in the height. Still use your formula. Now that 16 transfers down here. I'm going to need to find this part right here. This is going to be my height. I'm going to need to find it. I'm going to need to find this part right here because that's going to lead me to this entire base. You probably are going to use some trig. We could use some SOHCAHTOA. We could use 30, 60, 90s. We're going to use some things right here in order to solve some of these problems. And the same thing's going to happen on this other side when you draw this one in. To find this piece right here, we'll call it Y. You're going to need it to help you find the entire base 1. We know what base 2 is. It's 16. All right, so there's just some hints there on that one. And then we went ahead and threw this in here for the area of kites. These are very straightforward. These are not difficult at all. The main thing you got to remember is that the diagonals of a kite are perpendicular. So that means I have a bunch of right triangles right here. So I'm going to do, if I just did one triangle at a time, this would be 3 by 9 and find the area of that. And I have 2 of those. So I would do 3 times 9 divided by 2 because that's the area of a triangle. But then I have 2 of those. Okay. Then I would need to do the same thing over here on this side. I've got 2 of these. That's 3 by 4. On that one, so 3 times 4 divided by 2, but I have 2 of those. Okay, so that would take care of this side here. All right, and you can see how that would add together. These would have to add together to get your total sum down here for area. So kites, there's not a special formula for kites. Actually, there may be if you Google it or look one up, but this is how we're going to do it. Just think triangles. And you can see these angles down here. You may need to do some trig on that one. All right. I'll help you with this part in class. This also has some trapezoids on it, but you could go ahead and do it. Okay. See if we can finish that.